Well, I'm going to try to make a 2-turn by 3-layer coil. And I'm using soft copper tubing. Already got a little bit of a flat spot in it. Thought I had done better than this with 1 inch before, but at least it's not closed up all the way. Now, kinked. To get rid of that kink. Got to keep that pulled tight up against my 1 inch diameter form to keep it from kinking. Okay, so this is kind of a cheater because I've got a groove cut in here that the tube just fits into. So now I've got to kind of unwind it to get it out of that groove. Over that. There. Okay, so I've got almost 2 turns. Now I've got it out of there, so now I'm going to try to hold it tight on there. A little more. Now I've got enough room in there, and it's not too bad. It may be slightly flattened, but it won't be a problem. So now I need to go bigger. And the idea is I need to go to my next roll now, my next layer. hard to see where I'm going, because I got to stay right on top of that inner layer. I shouldn't let this get smaller. That's the second layer. This is the third layer coming along. Gotta keep pulling it tight to keep it in there. As long as I don't let any air between the two windings, I reduce the likelihood of a kink happening, like that. And of course, with each turn, it's making it a lot easier to do it because the diameter is bigger. Actually, I guess that's really my 3 layers, but I'm going to come around again, and one of the reasons is, so I'm overwinding it by at least a half a turn, because I'm going to have to unwind it to insulate it later on, and that's total guesswork on my part. I'm not doing this as to show you how an expert makes copper coils. I'm just doing it to kind of show what I'm experimenting with currently, and the whole idea behind this 2-turn, 3-layer coil is to get roughly 6 total turns on the coil to maintain the inductance so that we won't go out of range with frequency. So we're shooting for, on the 1000 watt induction heater that has 6.33 microfarad capacitors in it, which is where we'll use this, that we don't go beyond about probably even 115 or 120 kilohertz. Okay, let's see what we got here. Okay, so there's the coil. I've probably lost track of the turns now, but the point is that the ID is 1 inch, which is smaller than the last brass cartridge casing annealing coil that I tried. I want to get the power transfer up even faster without screwing up the gate signals and causing things to overheat. So there's that one. And you know what? I haven't been keeping track of the length of these coils. I really should pay a lot more attention so that I know how much material I'm using up. But there it is. Now, I found out a little while ago that even though this copper tubing is what they call soft copper tubing, just winding it up on the reel to prepare to sell it to people has work hardness more. So I found out when I did the 3x2 coil that it was kind of hard to unwind it to insulate it. So with this one, I haven't decided yet whether I'm going to anneal it first or not. I probably should. Yeah, I guess I will. Okay, here we go with the anneal. I'm I'm going to use oxypropane because I have it. That coil has got enough mass. It might be a little hard to heat with your small hardware store propane torch. So I'm just going to use something a little bigger. I'm going to have a kind of reducing flame here, and I want to be careful that I don't destroy my hard-fought coil. I only need to get it up to glowing red to do the annealing. I barely see it glowing. I'm looking at the oxide color changes. Since I'm heating this side and not heating the back side, I want to do this slowly so that the heat makes it all the way to the inner coils. I'm using these fire bricks to help contain the heat too. Okay, I think I've about got it here. Just do the straight parts a little bit. Okay. Now, it's often said you need to dunk it in water, and that's really not a very big deal. You dunk it in water to cool it down. You're not actually doing any annealing by doing that. The annealing is just from taking it up to temperature. The water is just to cool it enough so that you can handle it again. Okay, so I have cooled it off camera. Now I hope you can see the color is somewhat different. There was a little black oxide on there, but that just washed right off. So now I need to unbend it so that I first have enough room to get, so the coils don't touch, so I can get a inductance reading, and then secondly, so that I can get insulation on it. And I'm just roughly estimating there's about 4 feet of tubing here. So I'm just gonna try to loosen it up a little bit, and believe me, it is really easy to unwind now, or to deal with at all. So this isn't what I do for a living, so if I look like I'm a little nervous at doing it, it's because I am. Again, this first loosening up is to get a rough inductance reading. I mean, it should be plenty. And then, of course, it'll change and reduce a little bit again when I insulate it and then sort of wind it back up again. Let's see, I'm trying to keep track of where's the next place to unbend. I could add some insulating paper between layers so that the one layer, the new layer, wouldn't touch the layer before it, which might also help in the insulating process later if I chose not to go that way. I see that it reads approximately 1.23 microhenries. I already checked the zero of the meter. So that 1.226, 1.227, 1.24 as I take it a little further away from the steel table. And just for grins, what if I stick something that's metal in there? 1.174. So it always has surprised me how little the inductance changes when I stick some steel into one of these air coils. Anyway, about 1.22 microhenries. And I know this will change by the time I get it rewrapped after it's insulated, but that's definitely in the ballpark. It will work with the 1,000-watt heater without screwing up the gate signals, which would, as we know, cause the MOSFETs to overheat. Okay, I'm going to begin the process of insulating this. I got about 6 feet of material. That should be enough from my gross estimate that there's about 4 feet on here. I push it from this end to make it expand, and then it doesn't grip so much and it makes it a little easier to get it going. And the first few winds, of course, where it's loose are pretty easy, but I push some new material on and then I just kind of work it around. Push some new material on, work it around, you know, each turn you got a little further to go and a little more interference. Okay, so now what I'm doing is I'm expanding the coils as we go, but just enough to get the insulation on. And I don't know if you want to see me through this whole thing or not, but obviously it's going to get tougher and tougher as I get to the center. But at least since I've got insulation on up to that point where it's tough, I can kind of reliably expand things without kind of going overboard in the process. I'm trying to minimize the number of times that I bend any given part. Can't say I'm all that good at it, but that's the general intention, so that I don't rework hardened things any more than I absolutely have to. And I've gotten this insulating material from a couple of different sources. What I've usually been using is something that's called a 240 degree C fiberglass something or another that I get off of it's either eBay or Amazon. But also there's a guy local, fairly local, I live in western Wisconsin, so there's this guy in Otsego, metalworks.com, and he sells some of the smaller commercial units, induction heating units, and he also sells these materials. I know this isn't really much in the way of entertainment value, but that's what I'm up to. And of course, as I mentioned earlier, I'm pushing the material ahead of me, so it's easier. It's less of a grab on the pipe. But later on, then I will take care of that. Here I'm running into interference between these two coils, so I'm going to have to think about that. Let's see, which thing do I do next here? Got to open the whole works up to actually do that. There, I kind of moved things a whole bunch there. as I said earlier, I just don't want to do any more than I absolutely have to. And yes, if it looks like I'm fidgeting around as I do this, you're absolutely right. I am fidgeting around as I do this. But that's the way I've been doing it so far. Again, I have seen a couple of guys who have done the insulating before they bend it. Before they bend it at all. And I think if you're making coils that are over about 1 inch ID, 1.25 ID, that's probably going to work out just fine without having to anneal the tubing as you just saw me do a little bit ago. Okay, let's see if I can make it some more here. Actually, I really should be out there mowing the lawn for the first time this spring, since we've had such a wet spring. But I'd rather do this. And of course, there are also people who don't insulate the coils at all. I've just spent way too much time replacing MOSFETs from shorting things out that I don't like that idea of leaving those coils able to short out. Also, when I'm doing this multi-layer stuff for sure, really any coil, but the multi-layer stuff for sure, I think I'm in a bind again here. When I'm doing the multi-layer stuff for sure, I don't want the turns to short out on their own. And there's always that possibility that even if you don't short the turns with the work itself, that you could inadvertently tap your coil and short a couple of turns together. And most of the 1000, 1800 watt and 2500 watt heaters don't have built-in protection, overcurrent protections. I see there are a few models that are coming out these days that do, and that's kind of interesting. We're getting there. Of course, the further you go, the harder it is. So, shove some more on here. Where was I? Anyway, so you could inadvertently touch your coil if the windings are close together, which you usually want, and just short out a couple and wipe out some MOSFETs or damage some of the other gate circuit components usually, and then you're into soldering stuff back together again. And the problem with that is that the boards are not designed to be soldered and soldered and soldered on. And so if you've seen my other videos on troubleshooting and repair, you have also seen that I've spent some time adding new pieces of wire and things to the board itself when the board has, where the traces have actually given up and let loose. we're kind of on the home stretch here. We got about a turn and a half to go. Clearly it's the hardest still, but we're getting there. From the looks of things, my rough estimate that this coil took up about 4 feet of copper tubing wasn't too far off, as I showed at the beginning of this insulating video, or segment, as I showed at the beginning of this insulating segment. I had about 6 feet of the fiberglass, this insulating stuff. This is, I don't know if this is I don't know if this is the fiberglass or what they call a ceramic. I just don't remember. I guess I bought enough of it from different places. But looks like, you know, I might have, I don't know, 1.5 feet, 2 left out of 6. So certainly would be good maybe to put marks on the coil, on the copper tubing while it's still in the wrapper every foot or so, so that at least you could meter it out within a foot's worth of wherever you wanted to go. So, along with all this other stuff that's going on here, I've been assembling over the last actually 1.5 years or so a spreadsheet where I try to put down all the coil information that I know, that I've gathered so far. And the whole idea is to be able to predict, to accurately predict how the coil is going to behave before you even try it in the machine. And I think I'm pretty close. I've probably said this 6 times before, but it appears about 0.7 or 0.8 microhenries is the minimum inductance to use, probably on all 3 of the units, 1000, 1800, and 2500 watt, but for sure on 1000 watt unit, in order to keep the frequency down to the point where the MOSFET driver circuits can turn the MOSFETs on fast enough that they spend very little time in the linear mode. And now I'm almost done. I could quit there, but I'm going to go probably another inch. So maybe I'll try to get that without adding any new stuff and kind of just push everything along. This is a lot easier to do when it's plain, you know, what they call a solenoid coil. Just a bunch of turns that are all vertically, one above or one below another, or whichever way you say that.
I still really believe there's enough looseness in there to get me where I need to go. I'll give it one more shot. I can't. I should give up there, but I just want it out to here so that there's no possibility of a screw up anywhere along the line. And I can do it. It's now just busy work because I know I've got the room between coils so that, you know, I can keep it moving like this. Whereas most of the way of doing this, I was having to be concerned about having enough distance between the coils so that they weren't rubbing on each other, keeping me from doing what I want to do. Okay, there. So there we are. The next move is going to be to put this coil back together, so to speak. Okay, and I ended up with about 24 inches of material left over. So it was about 4 feet that it took. Okay, now let's see how much of this I can wrap back up. I've partially work hardened it again, of course, so it may not want to come back together as tightly as I want it. In fact, I don't even know if we'll know exactly where we're at here. This is supposed to be a 2-layer, 3-turn coil. Let's see here. 1, 2, 3. Okay. Okay, so it's not the prettiest thing in the world, but there it is. Now we'll check the inductance again and see how much change we made by all that screwing around. All right, now we'll check the inductance of this newly made sort of coil. This little meter has got a USB mini jack in it, and there's also a barrel jack, which kind of implies it could probably run off of 9 volts or something, but I don't recall. Anyway, 1.420 microhenries. Let me double check 0 and just make sure 0 is correct. Yep, 0 is correct. So 1.426 microhenries. 1.426 microhenries. And then just for grins, I'll stick this same punch in there and just see if this changes a greater amount now that the turns are closer together. 1.422, 1.37, I don't know, maybe that's a lot. 1.37. Okay, anyway, that's what we get. That's what we got. This thing was 10 bucks or less. I've probably said it 50 times by now, but if you're going to get into this at all, why not invest the 10 bucks? You could make it back in an hour pumping gas or selling hamburgers, and it certainly is a valuable tool.